All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning the basics of Rust through Gemini, of course. Today we are covering the topic of lifetimes, which is great because this is one of those topics that I covered back when I was learning Rust through through the Rust book, the Rust manual. I covered the topic at the time, but I didn't really fully understand the topic. And I kind of feel like one of the reasons for that was because I kind of, I was pretty much dodging generics at the time, which again, it like now it seems really silly thinking about the fact that it was more like, I guess I was just trying to save time. I was like, okay, I'm probably not going to be using generics because, okay, I was coming from a C sharp and Python background. More specifically, C sharp. Like I was trying to connect it with C sharp, and in my C sharp days, I rarely ever had to implement generics. I use generics a lot, but I rarely ever had to implement it. So I was like, okay, maybe I'll be able to save some time here if I don't do that. If I don't learn about generics, I'll be able to save some time and instead use that time to learn something else in Rust. And that ended up being a bad idea because not understanding the concept of generics, it caused a lot of confusion for me. Like whenever I would see a generic function that's been implemented and there's like a where clause for it, all of a sudden I'm confused about what's going on there. Give me a second here. I need to open up my um. Oh, I need to open, and we are now reconnecting. Hopefully, before the disconnect protection runs out. Okay, there it is. So, yeah, yeah. I was dodging. I was dodging. Wait, just a minute. Yeah, I was kind of dodging generics for a while back when I was new to Rust. And very recently, we actually learned about generics, and um, I'm actually happy about the fact that I took the time to learn about generics because now there's a whole lot of stuff that makes sense to me, and any generics related thing that I see in the future, well, at least in Rust, any generics related thing that I see in the future, I'm not going to be as confused about it, and I'll also be able to use generics, like, for my own stuff in the future. So that's great. Now, um, today we are going to be exploring the concept of uh, lifetimes in Rust. Just a second here. I have a feeling that something over here might be. Well, I mean, to be fair, it could just be my laptop kind of slowly dying, and that's why it's misbehaving. Dude, I'm so tempted to move my setup from from my Windows machine over to my Linux machine. But before I do that, I'm gonna have to make sure that I'm able to move my VTuber application there, which I'm not entirely sure if I'm gonna do that. I'm probably just gonna rewrite the thing from scratch, um, perhaps in Godot, because now I'm going the Godot and Rust route. So I'm probably gonna rewrite the entire thing in Godot. Give me a second. Let me just adjust my mic. Yeah. So yeah, I'm probably gonna rewrite it because if I'm gonna be moving the thing over to if I'm gonna move my VTuber application over to Linux, there's a couple of settings I'm gonna have to change, and I mean it would be better for me to recompile the thing, but then that would require me to open up the Unity project, and I just don't want to do all of that. I would much rather just rebuild the entire thing from scratch in Godot this time and using Rust. Actually, that would be a good introduction for me. Um, for doing Rust and Godot things. Because yesterday I was doing research, actually on stream also. We were reading up on. I don't know if I brought anything up on screen that was Godot and Rust related. I did make sure to open up Godot, so there was that. But other than that, I don't remember if there was anything more I was doing. I opened up Godot. I had maybe something opened up in the browser, but other than that, I was just reading out the entire conversation that I had had with Gemini um, about uh, doing Rust related stuff in Godot. And after the stream, I started reading that entire documentation. And soon I'm going to be taking my first steps of Rust into Godot. What I'm thinking is, um, for the sake of doing it on stream, I will well, both for the sake of doing it on stream and for the sake of refreshing my Godot knowledge, I'll do a stream where I learn the basics of Godot, and I'll try to keep the scripting to a minimum, just so I'm not, getting too deep into the scripting side of Godot, and I'm sticking more to the Godot engine concepts. And then once I've refreshed my knowledge and also learned new stuff that I didn't know before about the engine and the editor and all of that, um, once it's time to move to the scripting side, then I'll just move to the Rust scripting side. The great thing is that the Rust Godot the Rust Godot manual, they have made it in such a way that, or at least the beginning portion, the starting portion where, they're showing you how to create your first script or whatever you want to call it, the Hello World version of Godot Rust. In that, they said that they're trying their best to keep it on par with the Hello World version of GD script, which is being taught, you know, on the Godot website or on through the Godot manual, because when you're learning Godot, then they encourage you to use GD script, and so any of the scripting related examples, any kind of logic that you have to code, all of it is going to be in GD script. I think maybe they did have. I don't remember if they had that kind of thing where they give you different versions like GD script and C sharp and C++, but there's definitely a GD script thing, at least from what I remember. But to be fair, what I'm remembering is from, you know what? Why am I constantly guessing this stuff? I can just look it up right now. Give me a second. I'm gonna open up the browser, and in the browser, I'm gonna open up Godot manual. Uh, Godot. Okay, GodotEngine.org. Let's go to that. Give me a second. Okay, great. So here we open up Docs, because I remember yesterday, I think when I was opening up this website, it was causing all sorts of lag, and it was crazy. Oh, by the way, a bunch of the like creative coding related stuff or simple graphical application related stuff that I wanted to do previously with Nano. Now I can do those things in Godot instead with Rust, of course. Just a second. I have something that I need to make sure to write down. Rust project ideas. There it is. Okay. So, to this, I can add one more thing, which would be, oh, yeah, visualizing n-dimensional, visualizing n-dimensional data. Yeah. Okay. So this is done. We are, wait, hold on. Yeah. Okay, so we are looking at the documentation for Godot 4.5. I don't remember which Godot I downloaded. Hold on, give me a second for that. Give me a second for that as well. Let me just move over to Yahtzee and check what I downloaded because I placed it in my programs folder. So we have Godot 4.5.1. Okay, done. Awesome. Come back here. Yeah, so I have Godot 4.5. I don't know what uh, new stuff has been added, but considering that I'm pretty much a beginner still in Godot, I don't think I need to concern myself too much with that. I do want to explore it just to, just in case if there's stuff that uh, I, as a beginner, can also benefit from. Maybe there's been some workflow improvement that I should know about or something like that. I'm pretty sure the documentation will be up to date for that as well, if that is the case. What's under engine details? Oh, that's interesting. Okay, hold on. I'm interested in seeing what this looks like. And yeah, we can close this. Getting started, and then introduction. Let's open up introduction here. Under about, they had this thing of like, okay, how you should be using this. I forgot where that was. What can the engine do? How does it work and look? Programming languages. I wonder if they've mentioned Rust here because they have mentioned the others. Okay, with GD extension technology, you can also write gameplay or high performance algorithms in C++ or other languages without recompiling the engine. You can use this technology to integrate third-party libraries and other SDKs in the engine. Okay. Of course, you can also directly add modules and features to the engine as it's completely free and open source. What do I need to know to use Godot? Godot is a feature-packed game engine with its game engine with its thousands of features. There is a lot to learn. To make the most of it, you need good programming foundations. While we try to make the engine accessible, you will benefit a lot from knowing how to think like a programmer first. Godot relies on the object-oriented programming paradigm. Being comfortable with concepts such as classes and objects will help you code efficiently in it. Okay, cool. Um, right, so this is what it looks like. The interesting thing is I think when I open up Godot in my on my Linux machine, this is the scale that I'm looking at usually. And that's because like the screen is small, so it's limited to I think 1366 by 768. I believe yeah, it's either that or maybe slightly higher than that. One of the two. And so if I try to make the text and the UI scale, smaller to fit more things into the screen, then the text itself would be really tiny, and then it's kind of unusable for me. I run into that same Unity kind of situation, and I don't want to do that. But that's also why I'm glad that they have the option to, scale the UI, because that helps immensely. Like, I'm not even exaggerating about that. That is incredibly helpful. Okay. Now, hold on, dude. Why am I digging deep into this? I need to, we need to go back to what do you call it? We need to go back to learning about Rust lifetimes. But before that, there was something that I wanted to show over here. Okay, learn to code with GDScript. No, I want to go through like in some sort of like beginner tutorial kind of thing. Um, okay, there's learn to code with GDScript. Let's see what pops up here. Learn in your browser with the GDScript app. Wait, was this a thing before? I don't think this was a thing before. Hold on, dude. I don't think this was a thing before. Or if it was, then I just missed it. But to be fair, I haven't touched Godot in a good like 1 or 2 years or something. When was the Unity fiasco? Hold on. I'm curious about this. Give me a second. Let me just Google this. Unity licensing fee drama. As much as I hate the word drama, let's look that up, because that's kind of, you know, that's when a lot of the drama and news channels kind of, jumped in on this. So I'm hoping to find dates somewhere or timestamps or something. Okay, the Unity licensing fee drama refers to the massive 2023 backlash when sorry, when Unity announced a controversial new, why am I reading that entire thing? 2023. It was in 2023, and we are in 2026. So it's been a good like 2, if not 3 years. Um, so I mean, in that time, they might have launched this project, which is great. That's pretty awesome. Hell yeah, dude. Okay, overview of Godot's key concepts. So I need to learn about these. And at some point when it gets to, yeah, you know what? Okay, let's take a look at Introduction to Godot. Does this load that? Yeah, this loads it. Okay, what is Godot? Okay, what can the engine do? Give me a second here. Okay, maybe I shouldn't be doing this middle click thing because it kind of freezes everything. Let me just stick to doing the page up, page down. Yeah, the whole thing is stuck now. Okay, cool. So, how do I? Oh, I can open it up elsewhere. I'll open it up on my other machine, and then I'll read from there. And once this unfreezes, then we can read from here. Okay, it's unfrozen. It's I guess defrosted. Wait, that's crazy. That's crazy. Holy shit. Okay. Okay, how does it work? How does it look? Now, okay, there is Okay, programming languages and so on. So yeah, maybe I should just go through this entire thing and like read through it again. Um, this is under introduction, right? So we do this and then we go to learn to code with GDScript. That's just this one section. Then we have overview of the Godot key concepts. Then first look at the interface, learning new features, Godot's design philosophy, okay, and then there's a step-by-step thing, nodes and scenes. Nodes and scenes, creating instances, scripting languages. Available languages, which language should I use? Creating your first script. This is all under scripting? Yeah, this is still under, well, no, this is under step-by-step. Give me a second here. Okay, where was I? Yeah, creating your first script, project setup, creating a new script, hello world, turning around, complete script, okay. How, okay, listening to player input and using signals. Okay, so we can probably do this entire thing step by step. I don't think, um, yeah, I don't think until we get to the scripting part, I don't think there's any other scripting involved, like in these sections. I could be wrong, but like there is a certain amount of like editor related stuff that you have to learn as well that they're teaching. I mean, there's a certain amount of editor related stuff that they're teaching as well. It's not all very heavily scripting focused, but then of course scripting does come in because you have to script the logic for various things. um, if it is small enough, like okay, let's open up hello world, I guess. On the side as well, I can, well, no, I probably shouldn't open it up here. I do have the other thing open. I have Godot Rust open on another machine. Okay, it says um, this tutorial or the tutorial is heavily inspired by by creating your first script, which is this section, creating your first script from the official Godot documentation. I'm reading Godot Rust, by the way. That's where it's saying that that tutorial is very heavily inspired by this specific section, which is creating your first script. We recommend to follow that alongside this tutorial in case you're interested how certain GD script concepts map to Rust. Okay, all right. So create a Godot project, create a Rust crate. Yeah, so I guess this is after you have created the project, right? Because then there's the Godot thing, the Godot directory, there's a Git directory. I guess later on you create a Rust directory as well. So you create the Godot project, then you create a Rust crate, and then there's a bunch of Rust specific things that you have to do. Right. So, yeah, we can kind of revisit Godot. Um, wait, okay, creating your first script. How big is this section? I wanna see that first. Because like we can kind of okay, creating your first script, attach script. I need to also see how different it would be to do the to do this exact stuff in Rust. Because even in that example, on the Rust side as well, here they're extending Sprite 2D. There they extend iSprite 2D. Um, so like, same thing. They're following the they're following the tutorials like structure, and then they explain a bunch of things. Okay, there's hello world. All right. Yeah, okay. So maybe I should be doing this side by side just to avoid confusion. So we have this entire section. Okay, we can learn all of this. We can do a tiny bit of like, GD script stuff. Um, I need to see if, okay, so there was a hello world thing. Then there's using the Godot API, built-in objects, no, built-in types, then objects, then calling functions, registering Rust symbols. Okay, okay, okay. Yeah, all right. So after we have done hello world, um, after that we're kind of gonna have to just continue exploring on our own. And oh wait, this also goes into. Okay, so maybe we don't need to touch the GD script side because this is essentially replacing that, but I will have to like read both of them because one side teaches me about Godot and the other side teaches me about doing Rust in Godot. Give me a second here. I'm just scrolling through this. Okay, physics process. There's a function called physics process. They defined init and they also defined physics process. Um, oh, this is what I was talking about. So you have a GD script and C sharp. So they're showing you two different versions here. Okay, process. So process, we turn it into physics process. Okay. Yeah, yeah. So I'm gonna need to do both of these. I'm gonna need to do both of these side by side. Okay, launching the Godot application. Unfortunately, there is a GD extension limitation that prevents recompilation while the editor is open before Godot 4.2. Since 4.2, it is possible to hot reload extensions. This means you can recompile your Rust code and Godot will pick up the changes without needing to restart the editor. Holy shit, dude. Imagine having to close and reopen the editor each time you make a change. That's crazy. It prevents recompilation while the editor is open before Godot 4.2. Well, the good news is that we are currently on 4.5 and we've dodged that bullet. I don't think we need to worry about that too much now. Um, yeah, so it'll pick up the changes without needing to restart the editor. However, if you don't need to modify anything in the editor itself, you can launch Godot from the command line, even if your IDE, or even in your IDE. Check out the command line tutorial for so and so. Okay, great, awesome. We don't need to worry about that right now because, or we don't need to worry about that anymore because, Godot 4.5. All right. Okay, so we did the spinning thing. Next, we are doing the orbiting thing. All right, so we are pretty much closely following this. So eventually it gets to, oh, wait, that's crazy. So this is the end of the tutorial, right? This is the end of this specific tutorial, and the rest seems to be just user notes. like comments and stuff. I thought the entire page was just massive. Okay. Yeah, so they're closely following all of this, even in the Rust side. Okay, our node currently moves by itself. In the next part, listening to player input, we'll use player input to control it. Right, so that goes here. What does the complete script look like? Hold on, I didn't look for that. Uh, this is listening. This is this. This is this. This is the entire script, and the Rust equivalent of this. The Rust equivalent isn't all that big. We do need to create that struct, so there is that. But then I think the struct contains this stuff, player and angular speed. Yeah, yeah, I think so. I don't remember, or maybe we put that somewhere else. No, it says self dot angular speed. Yeah, yeah. So we put it into the player struct. Okay, all right. Okay, this is exciting. I guess we are restarting our Godot journey. How far are we into the stream? I've just been yapping about Godot and Rust rather than doing the Rust lifetimes thing. Let's get back to Rust lifetimes. So, um, let me open the thing up here. Okay. Is this broken up? Hold on. Yeah, I think it was broken up. Yeah, yeah. Now we can read it properly. Okay. Lifetimes are a core concept in Rust that guarantee memory safety without needing a garbage collector. They ensure that references never outlive the data they point to. This prevents a class of bugs known as dangling references. What are dangling references? Imagine you have a function that takes, imagine you have a function that creates a string, then returns a reference to that string. If the string is created inside the function and then goes out of scope when the function ends, the reference you create, the reference you returned would be pointing to invalid memory. That's a dangling reference. Dereferencing it would lead to undefined behavior, often a crash. Rust's borrow checker, which you've implicitly been working with since chapter one, uses uses lifetimes to analyze your code and ensure that this never happens. If it detects a potential dangling reference, it won't compile your code. Okay, give me a second here. I'm just uh, doing something. Where's the thing to close this? There, close the tab and open up a new tab here because that other tab for some reason was misbehaving. I just need to make sure I have some background sound. Okay, this is taking time as well. Never mind. Where was I? Yeah, lifetime annotations. So, lifetime annotations are a way to tell the borrow checker how the lifetimes of references relate to each other. They describe the relationships between references. They don't change how long references live. Okay, they start with an apostrophe and are usually lowercase, like so and so and so and so. You often don't see them in simple code because Rust has lifetime elision rules that allow the compiler to infer simple lifetime relationships automatically. However, when the relationships are ambiguous, you'll need to specify them. Okay. Lifetime annotations in functions. The most common place you'll explicitly need lifetime annotations is in function signatures, particularly when a function takes references as input and returns a reference as output. Consider a function longest that takes two string slices and returns the longest one. Oh, it takes two string slices and then they kind of get. Wait, string slices are not stored on the. Oh, it's a, what do you call it? It's a reference to a string slice. Okay, okay. Hold on. A string slice is is basically a reference. Why did I say, oh, it's a reference? Hasn't that made a difference? No, a string slice is basically a reference. But then I'm guessing in this case, it get both of them get cleaned up um, at the end of the function. So if we try to return if we try to return that specific string slice, then we end up in a situation where there's a dangling reference. So okay, we can test this out. Give me a second here. I don't know why this system is kind of misbehaving right now. Okay, you know what we could do? I could open up somebody else's stream on this end, and that audio is not going to be showing up. So, oh, wait, I had this thing open. I didn't think about that. Oops. That explains why my fans were going off. Right. So, we'll open this and turn the audio down. Okay. All right. So, where was I? What was I? Oh, yeah, here. So, here we're going to create um okay. Fn longest str. I remember this example because this was also the example that was given in the Rust manual. So we create a function that takes two string slices and then returns the longest of the two. And in this case, because we know they're both strings, so we can do something like this and this. And in case if x is longer than y, we return x, else we return y. So now here there's an error. It says missing lifetime specifier. This function's return type contains a borrowed value, but the signature doesn't say whether it's borrowed from x or y. Wait, so that's the issue? That it doesn't say whether it's borrowed from X or Y? And the lifetime specifier is what tells you whether it's borrowed from X or Y? hold on. But then we're going to be adding this lifetime specifier to both of them. Okay. Um, let's see what this is saying. Hold on. What's going on here? Okay. I should do it from here instead. Okay, the Rust compiler doesn't know if the reference it returns should live as long as X or as long as Y, or potentially even longer if one of them is static. It needs your help. Here's how you annotate it. This this tells Rust that the returned reference will be valid for the shorter of the two input references. The shorter of the two input references lifetimes. Okay, so we introduce. Wait, I didn't understand this. So this tells Rust that the returned reference will be valid for the shorter of the two input references lifetimes. It'll be valid for the shorter of the two input references. This vocabulary is kind of confusing me. I think it's the vocabulary that's kind of confusing me. Yeah, yeah, I think so. So in one case, we have a string, which is a reference, or well, we have a string slice, which is, well, a string slice. It's a reference. And then we have a string, but we are returning a string slice of that. So we are returning that as a string slice, or passing it in as a string slice. Sorry. And then the longest function returns a string slice. Uh, Result lives as long as string 1 and string 2. Okay, hold on. So so and so declares a generic lifetime parameter named apostrophe A, and then so and so means both input references must live at least as long as lifetime A. And then the return type means the returned reference will also be valid for at least lifetime A. The borrow checker then ensures that wherever result is used, its lifetime apostrophe A is valid, which in this case means it must not outlive either string A or string 2, string 1 or string 2. Give me a second. I need to check something in my OBS. I need to make sure it's muted. Is it muted? Yeah, it's muted. Okay. Though, to be fair, the OBS from which I'm sending the RTMP stream, I don't think, well, it even if it does end up sending the audio, I don't think I'm consuming the audio from the RTMP stream. Okay. Yeah, I'm still like I'm kind of getting it, but I'm not fully getting it. It's this wording that's kind of tripping me up. Yeah. Um, okay, let's move on to the next thing. So, lifetime annotations in structs. If a struct holds a reference, you must specify a lifetime parameter for that reference in the struct's definition. Hold on, give me a second. I need to hydrate. So I'm just gonna, in the meantime, I'm also gonna try and restart the browser on this other machine. Okay, the browser has restarted. I'm going to try and load up Twitch here. Okay, I think hopefully this time we can. Yeah, yeah, this time we are good. We are good. So I can probably close this and we can continue here. Let me just unmute this and have a tiny bit of audio. Okay. All right. If a struct holds a reference, give me a second. Yeah. If a struct holds a reference, you must specify a lifetime parameter for that reference in the struct's definition. This tells Rust that an instance of that struct cannot outlive the data it refers to. An instance of the struct cannot outlive the data it refers to. Okay. All right. Yeah, let's take a look at this. So, struct important excerpt. Wait, is this showing up on stream? Yes, it is. Okay. Um, yeah, important excerpt. Actually, I didn't do that. Um, the example that was specified, right? So let me just do that. Okay. So that's done, and now we specify it here and here and here. There. Now we are good. Now we are good. All right. Now, carrying on. So, important excerpt. This is a struct that holds a string slice And we are basically saying that the string slice must live as long as the struct. Oh, so the idea here is that because it's holding a reference, so that reference could possibly go out of scope and then get cleaned out by, the borrow checker. And well, cleaned out by the borrow checker or by Rust or one of the two. I'm assuming because the borrow checker is the thing that's checking, the references and stuff. So that's what's going to also perform the cleanup process. I don't know. Either way, cleaned up by Rust, because there's a chance that this could be cleaned up by Rust. If it does get cleaned up, um, then this field is basically going to be a dangling reference. Initially, what I was thinking about was um, the struct itself as a thing in memory, and then you have the reference as well. And so I was like, okay, I was trying to compare like the lifetime of the struct, not the field, the lifetime of the struct to the lifetime of this thing. But like, that's not the problem here. The problem here is if this thing goes out of scope or it gets cleaned up for whatever reason, now all of a sudden you have an empty field in important excerpt. Sorry, zoned out. Okay. So, struct, important excerpt. Okay. Then in the main function, we create a novel, which is a string, and then we create a first sentence, which pulls the first sentence from this string and gives us that. What does expect give? Hold on. Let me recreate this. I think we are done with all of this, right? So we can get rid of this. Now here we'll do struct important excerpt, and we do this. Okay, then part so and so str. I wonder if there's a way to avoid this thing. So like I do this and then this, but then I have to do this. So like I type, the single quote. I only need the single quote. So that's how it becomes an apostrophe, right? But then I have to delete the second one because by default that's the behavior. It assumes that if you're creating an open quote, then you're going to have a closed one, which the majority of the time that is the case. Yes. So yeah, how do I go about this? Okay, I guess that's the only way. So we do this and then this. All right, fine. Then in our main function, we do novel. Hold on, let me bring the keyboard here. Okay, we do novel equals string from call me Ishmael some years ago dot dot dot. Okay, then first sentence equals novel dot split, and we split based on dot. What does this function take? Okay. Oh wait, this is split off. Did I do split off? Okay, I did split off. There. Um pat p, it's a pattern. Okay. I think P is oh, this is a generic dude. Okay. Okay. See, this is why I'm glad that I learned generics, because now I can tell that this is a trait bound generic. This is a trait bound parameter. So whatever I'm passing in here, it can be any type that implements the pattern trait. And now I also can assume that pattern is a trait. Actually, hold on. Pattern. How do I see if this is a trait or not? The trait itself acts as a builder for, okay, this is a trait. Okay, so pattern, not a. What am I looking for? Oh, this. I'm looking for the full stop. Right. Then we do expect. No, we do next because it's an iterator. So this returns an iterator. Split is an iterator. I need to learn I need to learn how to read this as well. This thing. Like what is going on over here? Because it seems like there's a lifetime and a generic parameter being specified. It's not a lifetime for the generic parameter. Oh, the parameter that's being returned, well, the type that's being returned is what has been passed in. I don't know what split is exactly here. This is returning split though. I know that. Oh, this is interesting. I just noticed this. P equals char. So that's the returned iterator will be a double-ended iterator if the pattern allows a reverse search and forward slash reverse search yields the same elements. The returned iterator will be a double-ended iterator if the pattern allows a reverse search and forward slash reverse search yields the same elements. Okay, I didn't fully understand that, but okay. This is true for example char, but not for str. If the pattern allows a reverse search, dude, okay, never mind. This returns an iterator over substrings of this string slice separated by characters matched by the pattern. All right. Okay. And then we are doing next to move to the next item. All right. And this, what does this return? This returns an option because of which we have to do expect. What does option give you? Option is sum or none, right? So then expect is going to give you the sum, but it's going to panic if there's a none. All right. Oh, backup. No, backup. Hold on. Returns the contained sum value consuming the self value. Okay, returns the contains some value consuming the self value. This panics if value is none. So what is the behavior we are going for here exactly? Okay, some value um, x dot expect Okay, this panics. Okay, all right. So this is a way of checking if. No, see, this wording is kind of confusing to me. Yeah, this wording is kind of confusing to me. Oh, this is Markdown. That's interesting. I didn't realize that. Or, I mean, it might be some other form of some other kind of Markdown. Maybe not necessarily Markdown, but okay. So, um, it says it returns the contained sum value consumed. It's not giving any like. Yeah, no, no, hold on. This is a little bit confusing. Rust expect. Expect method is a utility for error handling that attempts to extract the inner value of the so and so. And if it's an error or none variant, no, but okay, why are we giving why are we giving it a string slice? Like what's the idea there? That's what I'm confused about. Oh, you're joking, dude. Okay. I wasn't paying attention. I was assuming that it was some kind of comparison kind of thing, but no, the string value that we are giving is the message that's going to be returned if it panics. Okay, I just wasted a whole bunch of time. Um, right, could not find a so and so. So it's going to panic if it couldn't find the thing. Right, and then I equals important excerpt, and here we do part first sentence. Okay, here important excerpt has a lifetime parameter, and the part field is a reference with that lifetime. Sorry, zoned out. Okay. And the part field is a reference with that lifetime. This tells Rust that an important excerpt instance cannot outlive the refer. Oh, that's interesting. Okay, so earlier I was mentioning about like the lifetime of the struct versus the lifetime of its of the string slice that's being held within the struct. And I was like, okay, that's not the case here, but it seems like that is the case here. The concern is that one of them is gonna outlive the other. So here they're saying that this tells Rust that the important excerpt instance cannot outlive the reference it holds, in its part field. Because if it, wait, no, isn't, how is that? Oh, yeah, okay. The reason it cannot outlive, the reason why the struct shouldn't outlive the reference being held inside it is because if the struct lives longer than the reference being held inside, that means that the reference being held inside at some point dies out, right? And if the struct is still alive at that point, you then have a dangling reference. Okay, all right. Practice exercise, getting the message. Hold on. I need to, I'm still a bit hung up on on that wording. Okay, you know what? I can ask the question later on. Let's see if I'm able to even do this exercise, because like I'm in this weird spot where I kind of think I've understood it, but I kind of also don't. I'm not really sure if I've understood it. Let's see. Okay, let's write a simple function that takes a reference to a string slice and returns that same reference. This seems trivial, but it explicitly requires lifetime annotations to make the compiler happy. It takes a string slice and returns the same reference. All right. In your main.rs, define a function called getMessageRef. All right. Then this function should take one argument, a reference to a string slice. It should return a reference to a string slice. Okay. The function body should simply return the input reference. All right. You will need to add generic lifetime parameter. You will need to add a generic lifetime parameter to the function signature and apply it to both the input and output reference. Then in your main function, create a string variable, call get so and so with a string with a slice from S1. Okay. Store the result in a variable message and then print the message. All right, let's do that. So it's just a function that we need here, right? So let's do the function here. Fn, I forgot what was it? Get message ref. Get message ref. This takes in a string slice and returns a string slice. This pretty much just returns a. Just a second. Hold up. Okay. Right. This doesn't seem to be requiring. The function body should simply return the input reference. The input reference, so like a reference to a reference, won't the compiler like optimize that away? This expression creates a reference which is immediately dereferenced. Yeah, okay. Dereferenced by the compiler. Needless borrow. Yeah, there you go. It's getting rid of it. The compiler is not complaining about this though. Okay, let's try. So let's say S1 string from I don't know, something. And then call this and store it in message. Okay, message equals get message ref. s1 dot as str. Are we good so far? We're good. Okay. Print line. Okay. Then we, what is what is going on? Okay, yeah. Then we do this. Now this doesn't complain. Yeah, this is not complaining. Here's a skeleton to guide you. This exercise will give you direct experience with applying lifetime annotations in a straightforward context. Let me know if you hit any snags. Okay, hold on. Hey, so, oh, wait, what's going on? Okay. Hey, so, I tried doing this. Um, I purposely didn't use any annotation. Um, the function still worked. Let's see what Gemini says about this. Okay, you are absolutely right to call me out on that. That's a fantastic observation, and it highlights a very important feature of Rust, lifetime elision rules. My apologies for presenting it as if it would always fail without annotations. It was a simplification on my part, and your curiosity caught it perfectly. Lifetime elision rules explained. Rust's compiler is smart. It has, I like that we have a little like side quest in this tutorial now. I've actually had a couple of instances like this where it's not necessarily a wrong thing. Like it would have worked regardless. It's not like, Gemini got it wrong. I don't think Gemini said that it wouldn't work. Gemini just said that, do this, do this, do this, um, and it should work, which is technically true. Like even if I would have added the lifetime annotations, it would have still worked. I am curious about if Clippy would have said that what I'm doing here is kind of useless. Eliding a lifetime that's named. Clippy, the following explicit, there you go. Explicit, the following explicit lifetimes could be elided. I don't use this word nearly enough to know if I'm pronouncing it right. I think elision is right, but then is it elided? Elided, whatever. I'll look into it later on. Could be elided. Needless lifetimes. Yeah, there you go. Now Clippy is saying that this is pointless. So get rid of that and that and that. Okay. Carrying on with Gemini. Okay, Rust's compiler is smart. It has a set of deterministic rules to infer lifetimes in common, unambiguous situations. This allows you to write Rust code without cluttering it um, with lifetime annotations everywhere, making it much more ergonomic. For your getMessageRef function, this adheres to one of the primary lifetime elision rules for functions. Rule number one, each parameter that is a reference gets its own lifetime parameter. Okay, so implicitly it gets it. Okay. Each parameter that is a reference gets its own lifetime parameter. Okay. So implicitly, there's always lifetime kind of stuff going on, right? Implicitly, there's always lifetime annotation going on. We have to explicitly specify the lifetime in situations where it is not obviously clear to the compiler um, what the lifetimes are supposed to be, or in situations where it is obvious to the compiler that the lifetime isn't long enough. I think that's the case. Okay, each parameter that is a reference gets its own lifetime parameter. So input str becomes input str so and so. Rule number two: if there's exactly one input lifetime parameter, that lifetime is assigned to all output lifetime parameters. Um, since there's only so and so as an input lifetime, the return type ampersand str automatically gets the lifetime so and so. So the compiler effectively transforms your code into what I gave you, which is this. This is why it compiled and worked without you explicitly writing so and so. The compiler did it for you. When do you still need to when do you still need explicit lifetime annotations? You need them when the elision rules don't apply or can't disambiguate. The most common scenarios are multiple input lifetimes, ambiguous output, like our longest example. Here, the rule, if there is exactly one input lifetime, that that lifetime is assigned to all output lifetime parameters doesn't apply because there are two input lifetimes. Another rule states if there are multiple input lifetimes, but one of them is ampersand self or ampersand mute self, the output lifetime is assigned. Hold on, the output lifetime is assigned the lifetime of self. That's interesting. This also doesn't apply here, so the compiler can't infer and you must explicitly annotate. Okay, another situation, structs holding references. As shown with important excerpt, structs don't have elision rules. Is it elision or elision? I think it's elision. Okay, structs don't have elision rules for their fields. So you always need to annotate references um, within them. And the third situation is when a reference outlives scope, not in input slash output. If you have a reference inside a function that needs to live longer than the function's scope, or if the function creates a reference that doesn't relate to an input reference, or if the function creates a reference that doesn't relate to an input reference, okay, you'd need explicit handling, often by returning an owned value, not a reference. Right, your observation was brilliant because it forced us to cover these important rules. Does this clarify why your simple function worked and why others still need explicit annotations? Kinda. I feel like I kinda understand um, lifetimes and lifetime annotations, but I don't fully understand them. Um, I guess over time, with practice, I'll probably understand them. I am a bit confused about one line you mentioned, one thing you said about lifetimes. Hold on, I need to go all the way back up here. This tells us, this tells Rust that, hold on, can I, yeah, I think I can. I'm glad that I found out about that block, this block method. Just a second. I'm not sure what's in the clipboard right now, so let me just, okay, we are good. Um, you said this tells Rust that that the returned reference will be valid for the shorter of the two so and so so and so. I don't know if it's just the wording or hold on, wording or what, but I didn't really understand this. This tells Rust that the return reference will be valid for the shorter. Valid for the shorter. And I guess that's it. Like we are pretty much done with lifetimes now. And it's kind of funny because I still don't feel all that confident with lifetimes, but I still kind of feel like I get it. I understand that basically we are telling the compiler that, okay, um, this has to live as long as that, or, you know, one of these cannot outlive the other. I guess what we are more trying to enforce is that um, they both live as long as each other. I don't think that, no, I don't think that works, does it? Because like in the case of a struct, give me a second. Okay, all right. Voice crack. Holy shit. Okay. Um, okay. You are right to be confused by that wording, and thank you for asking for clarification. It's one of the trickiest parts to explain. Let me try to rephrase it with a more concrete analogy. Imagine you have, oh, okay, here we go with the analogy. Imagine you have two friends, Alex and Blair. Alex is going on a vacation. We are talking about lifetimes, and we brought up humans here. I just thought that Alex or Blair were about to die. Okay, all right. Alex is going on vacation and lends you their car. They will be back in 5 days. You must return the car before Alex gets back. No, hold on. Alex is going on vacation and lends you their car. Okay, they'll be back in 5 days. You must return their car before Alex gets back, or you must return the car before Alex gets back. Blair is also going on a vacation and lends you their bike. They'll be back in 3 days. You must return the bike before Blair gets back. Now, imagine I give you a function, choose vehicle. This function will look at both. We'll look at both and return a reference to one of them. The question for the borrow checker is, how long can you keep the vehicle that choose vehicle returns? How long can you keep the vehicle that choose vehicle returns? If it returns the car, you could theoretically keep it longer. You could theoretically keep it for 5 days. If it returns the bike, you can only keep it for 3 days. Okay. Since the function could return either one, the only safe guarantee is the shorter duration. Why? You must promise to return the vehicle within 3 days, because if you promised 5 days and the function gave you the bike, you'd have a problem on day 4 when Blair comes back to find their bike is still with you. A dangling no, this, hold on. That that analogy did not help. Okay, all right, let's move on. So this is what so and so longest means. Apostrophe A represents a borrowed duration, and then this says that both X and Y are valid for at least that duration. And then this promises that the reference we return will also be valid for the same duration. When you call the function, the compiler makes apostrophe A concrete. It looks at the actual lifetimes of the variables you pass in. Let's say X lives for 10 more lines of code and Y lives for 20 more lines of code. The compiler sees this and determines that the only duration that satisfies the contract for both X and Y is the shorter one. Oh, so for this specific function call, apostrophe A becomes the lifetime of X. The result is therefore only guaranteed to be valid for 10 more lines. After that, X might be gone, and if result was a reference to X, it would become a dangling pointer. So valid for the shorter means the return reference is constrained by the lifetime of whichever input reference lives for a shorter amount of time. Okay, now it's making some sense. The compiler enforces this guarantee. The compiler enforces this to guarantee you can never hold onto a reference to data that has been deallocated. Okay, so the analogy did not help, but your Rust related explanation did. Your Rust related explanation later definitely helped me visualize things a bit better. So let me see if I've got this right. The compiler needs to because this is a reference, the compiler needs to know how long the thing being referenced is gonna live. In our case, we have two inputs. No, wait. Yeah. Um, in order to determine this, it needs to create a lifetime to hold on. I need to, like, I've understood this concept. I need to be able to put it into words. Um, in order to determine this, it needs to create a lifetime to compare the lifetime. No. So, okay, it creates a lifetime, right? And then, hold on, it creates a lifetime. This lifetime applies to the inputs and the output. In our case, we have two inputs, and so the compiler chooses the shorter of um, the lifetimes between the two inputs and then enforces that the output should live for the lifetime of the shorter input. Oh, should live for at least the lifetime of the shorter input. This way, we can make sure that um, the make sure that the input or the reference input, or should I say input reference? The input reference with the shorter of the two lifetimes doesn't, though, is it the reference or is it the value that's getting cleaned out? Yeah, hold on. Wait, no, I'm not going to describe this whole thing because I feel like I haven't understood. Um, yeah, wait. I'm kind of getting it, but like also not getting it. Okay, I'm still a tiny bit confused though. Um, so is the lifetime um, talking about how long the reference to a value will live or how long the value itself will live? Hey there, Sionix. Hello, hello. How's it going? Welcome to the stream. We are doing a bit of um, We're doing some Rust studies here, and I'm trying to wrap my head around the concept of lifetimes. So I'm just asking Gemini some questions regarding that. I'm good. How are you doing? I'm okay. I'm okay. I'm just trying my best to get through this basics tutorial as quick as possible. Um, well, covering, each of the basic concepts. Right now we are on lifetimes. After that, we're going to go to iterators and closures. And after that, we're going to go to smart pointers. And then we go to concurrency, which is that goes into multi-threading and stuff. So like I'm excited for that. But once I've covered these basics, I have like a bunch of Rust projects that I want to get into. So like I'm trying to get through this whole thing as soon as possible. Now, I asked a question here, a clarifying question, and Gemini has given me an answer. That's the perfect question to ask. It gets to the absolute core of the concept. Lifetimes are about the validity of the reference, not the lifetime of the value itself. Let's be very precise. A value has a lifetime that is determined by its scope. When the variable that owns the value goes out of scope, God, you are speaking my language, but my head is hurting. Cool, cool. Hell yeah. Well, I mean, I hope your head stops hurting, but glad that I'm speaking your language. Hell yeah. Where was I? Where was I? Lifetimes are about the validity, so and so, so and so, so and so. A value has a lifetime that is determined by its scope. When the variable that owns the value goes out of scope, the value is dropped and its memory is cleaned up. Okay, great. A reference a reference also has a lifetime, which is also determined by its scope. The lifetime annotation so and so is the piece that connects these two things. It's a compile time assertion that says, okay, like I understand what you're saying, but it's giving me a headache because I know how painful it is to learn code. I like learning coding. That's kind of why I've been enjoying learning about Rust, and that's why I've been diving so deep into Rust. The more I understand about Rust, the more I can appreciate this language and the whole ecosystem that's built around it. It's just that some of the concepts, like lifetimes, for example, lifetimes, lifetimes, yeah, like lifetimes, for example, some of these concepts can be a little hard for me to understand because I'm kind of new to these specific things. There's lifetimes. There was also the concept of the borrow checker, like something that makes sure that you're following the rules of the borrow checker. Like for example, you can't have more than one mutable reference to something. At least not unless you're using one of the smart pointers. Um, and also you can't borrow a moved value. You can't. There's a bunch of like different borrow checker rules that guarantee memory safety. Initially, I was having a lot of trouble with that because again, it was like a new concept for me, coming from languages like C sharp and Python and stuff, where all of this just gets handled for you. And like if you're coming from C++, then you would usually be handling it manually. Though I think they did at some point introduce some level of automatic handling of those things, but for the most part, there you would be handling it manually. It's painful but fulfilling when you get it true, true, very true. That is, yeah, that is so true. Like once I wrapped my head around the concept of how Rust works, then I was able to like appreciate the various um I was able to appreciate the design of various libraries that I was using, and concepts like abstraction. Abstraction is a it's a very uh, it's a very common thing within Rust. Like you'll see you'll see Rust crates that are built for a certain thing. Like let's say it's a deep learning crate that allows you to both build and train and run. So train and run neural networks. But then this crate, it follows, or this library follows the concept of backends. So you're able to use different backends, enabling you to use this library on different platforms or in different, let's say, architectures. So, for example, one backend allows you to train and run the neural network on PC. Another backend, because it's using a NoSTD kind of a NoSTD type of backend, so you're then able to use this library through this backend on embedded devices. So you can do embedded Rust on ESP32, for example. The only language I know is Java. I so I've explored a bunch of languages over time. I think I touched Java for like 5 minutes a couple years ago. No, more than a decade ago. Actually, not even a couple years ago. It was more than a decade ago. 2 decades ago? Dude, I think it was close to 2 decades. I think it was close, maybe a decade and a half ago. I haven't really done too much with Java, but I have explored a bunch of other languages. C, C++, assembly, JavaScript. C Sharp is a language that I did for more than a decade. I think I have like 15 years of experience, if not 2 decades of experience in C Sharp. I've got a decade's worth of experience in Python. I'm still using Python quite a lot actually for data science and deep learning. And now Rust is something that I've been using for a while and will be using for quite a while. So I kind of pushed C Sharp to the side because I was mainly using it for Unity related stuff. So anything that I want to do now, even Godot, I'm planning on getting back into game development and doing creative coding and stuff. I'm going to be using Godot for that. Godot has support for it has its own native language, which is GD script. Then it has support for C Sharp and C++ as well, but it also has support for other stuff. So like you can write support for other languages, and a very helpful community of developers have worked on um, Rust support for Godot, and so I'm planning on doing game development in Godot using Rust. I want to explore more languages at some point because I'm still in school for software development. I would definitely recommend it. Yeah, I would recommend exploring multiple languages. Don't stick with just one language because multiple languages, they teach you different ways of thinking, but they also help you see more of the ecosystem. Let's say, like when you explore the Python ecosystem, for example, I personally would recommend getting into Python and Rust. Since you already know JavaScript, I wouldn't suggest getting into C Sharp, unless you have like a very specific reason why you want to go the .NET route. Dot, words .NET. Holy shit. .NET is still a pretty or C Sharp is still a pretty good general purpose language, but my personal recommendation would be explore Python and Rust. Whenever you get a chance to explore Rust, then explore Rust, but get into Python because Python is it's amazing for like overall general purpose, but also certain very specific things. Like for example, if you're interested in data science and deep learning, 100% explore Python. But Python is also being used for a ton of other things. The very concise syntax of Python, it makes it so you're not writing very verbose code. Like if you look at the code over here, all of this Rust code, this would be incredibly concise if it was done in something like Python, right? But then with something like Rust, you're not necessarily looking for verbosity, you're not necessarily looking for um, conciseness. So like it is verbose, but there's a reason for that, and you're not necessarily looking for something. When you come to Rust, you are basically looking for performance. That is why you're looking at Rust. So even if there is a lot more verbosity in it, it's not really a bad thing because there's very good reason for why things are a lot more verbose in Rust. I want to learn C++ or C Sharp because that's the popular job here where I'm at. I would recommend you do a lot more research on like which languages are currently being used a lot more. C++ is definitely a good thing to look into. Um, I can't say anything about like, how much it's going to continue to be used, but I can tell you that there's a lot of systems that have been written, a lot of technology that has been written on C and C++. So if the aim is to find a job in this, then yeah, you're probably gonna find it like for C++. I can't say anything for C sharp though. It's not that it's not being used. It's there's definitely a fairly active C sharp community still. But I just feel like a bunch of other things have kind of what am I trying to say? Like it depends what you are trying to do, really. Because like in my case, when I did general purpose C sharp for a couple of years, and after that I got into game development with Unity, and Unity was using C sharp. And so because of that, I have like more than a decade's worth of experience working with C sharp, but the majority of it has been in game development or specifically Unity related stuff. Even if I was doing like general, application development, it was still Unity focused. And then I had a few like one-off select few projects here and there, which were not aimed at Unity. They were general like console applications. And I decided to do them in C sharp because, well, at the time I just wanted to do it in C sharp. Now though, if I were to do those same projects, I would probably go with Rust or Python. That's just my personal thing. I will say this though, it you do have a certain level of comfort working with something like C sharp, for example, or not for example. In this case, working with something like C sharp, you do have a certain level of comfort because you don't have to worry about memory management. So you're able to handle a lot more higher level stuff, and you're able to build a lot more, sophisticated systems, which a bunch of people have done. Like during my time working with C sharp, I got to explore the ecosystem quite a bit, and there's a lot that has been done in C sharp. Yeah. Though, okay, I would definitely recommend looking into Python. I'm not discouraging the other two. I would definitely recommend looking into Python because whether you end up using it for your job or not, it is something worth looking into because it can help you in multiple ways, like a lot of different ways. But yeah, dude, I mean, best of luck with your learning. I forgot where I was reading this. Oh, a reference also has a lifetime, which is also determined by its scope. The lifetime annotation is the lifetime annotation is a piece that connects these two things. It's a compile time assertion that says the scope where this reference is valid cannot be larger than the scope the scope where this reference is valid cannot be larger than the scope where the value it points to is valid. Or more simply, a reference cannot outlive the data it refers to. Let's look at the longest function again with this in mind. Uh, right. This signature is not changing how long the original string lives. It's making a promise about the references. It's saying you give me two references, X and Y. We'll call the duration that they're both valid apostrophe A, and I promise the reference I give back, which is the result, will also be valid for the same duration. Okay, the compiler's job is to enforce this promise. If you try to use result after either of the original strings have gone out of scope, the compiler will see that the lifetime apostrophe A is no longer valid for result and will give you a compile error. So to directly answer your question, a lifetime annotation on a reference, a lifetime annotation on a reference is talking about how long that reference can safely be used. The constraint is that this duration must be less than or equal to the lifetime of the original value. I kind of feel like I need to read this over again a couple of times to properly understand what this is saying, or maybe I need to come up with some. Maybe I need to talk to Gemini, well, the Gemini web version, and get it to create a couple of like simple exercises for me that will explain to me how the concept of lifetimes is working exactly. Or should I ask this Gemini instance? Maybe I could just ask this Gemini instance to do that for me. Hey, I feel like if I did a couple of exercises on this, I would be able to understand it better. Um, is there any way you can? Well, I mean, there is. Obviously, there's a way. Could you generate um, three or four exercises for me that would um, help me? No, for me that I would solve to understand the need for and the concept of lifetimes. We can do them one by one. Okay, so this is going to be generated, and once this is I kind of don't want to move past this unless I've fully understood the concept of lifetimes. I was really excited to jump into iterators and closures, but I kind of want to. Wait, no, 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 hold up. The problem, your task, the code to write. This function will not compile. That is the point of this. Okay, okay, okay. Write this, run, carefully read this, pay attention to the parts that say returns a reference to so and so, so and so, so and so. Okay, 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 okay. This exercise is designed to fail. The goal is to see why it fails. Okay, let me know what you see in the error message and what you think it means. Okay, lifetime exercise one. Hell yeah, dude. Okay, so Gemini is going to help me understand lifetime or lifetimes more better. Um, right. Now, um, I unfortunately need to hold on. Let's go here and here and here. Give me a second. Okay, okay. All right. Okay, who should I go to? Okay, can't go here. Uh, okay, okay, let's restart this. Okay, okay. Man, I'm taking way too long for this. I am taking way too long for this. Let's try again. Okay, let's see what's going on here. No, we can't do that. Need to go elsewhere. Um, okay, working, so and so. Okay. Um, okay, so I'm having some trouble deciding, so I'm just gonna head over to Louise. We're gonna raid Louise. Louise is pretty chill. Uh, Louise is cool people. We're gonna go. Um, I spent a good like 4 or 5 minutes looking. Holy shit, dude. Okay, right. So we're gonna head over to Louise's stream. That's gonna be it for today's stream. Um, Holy shit, dude. We are on a pretty good stream streak. Approaching 3 weeks, I guess. I don't know. Because from the 3rd of this month to now the 21st of this month, it's almost 3 weeks, right? Because if it was from the 1st and then now it was 21st, then it would have been 3 weeks. So it's almost 3 weeks we've been streaming continuously, and I'm super happy about that. Hell yeah, dude. I hope it continues for longer. Um, HX and Sionix, thank you for hanging out. Thanks for chatting. Anyone else who might have been lurking in the stream, thanks for hanging out. I'm pretty excited about this progress that I'm making. I'm gonna try, you know what? I'm gonna try and finish the the iterators and closures chapter before tomorrow's stream. Now I'm saying that I'm gonna try and do this, but I don't even know if I'm gonna be able to do it. Okay, the timer is running out. That's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.